Hi everyone, this is Matt from OpenBuilds. In today's video, we're going to show you how to wire up your Acro. So it's going to be all inclusive, guys. We're going to show you how to connect your flex tubing, which is a lightweight application for wire management for this machine. As you can see, it's very aesthetically pleasing, looks great. We're also going to show you how to assemble your micro limit switches, your open case for your controller board, and we're also going to show you how to configure everything into the software. So by the end of this video, you're going to be lasering out a cool project. So let's go ahead and get started. Okay, so on this first step, we are going to be assembling our wires to our female connectors. So let's go ahead and start by identifying the parts that we need for this step. So we will need 4 conductor wire times 3. We have one at 9 feet and 2 at 6 feet. So let's go ahead and start off by assembling these to our female connectors. Now, as you can see, I've already pre-stripped these wires, so if need be, go ahead and strip those down. You should see these color wires inside the casing: yellow, red, green, and blue. So coming over here to the female connector, one thing you should pay attention to is the metal inserts inside the pen. So each one of these need to be loosened before you insert the wire. So as you can see, most of mine are loosened already, but I'm just going to make sure that they're fully open so they can accept the wire. So taking our 4 conductor wire, we are going to insert our wires in this order: red, blue, green, and yellow. So we're working right to left, and this is for the purpose of matching these wires up with our motor wires. So the male connectors attached to our NEMA 17 motors need to be in correspondence with our 4 conductor extension wire. So let's make sure that we order these correctly. So first, inserting red and blue, I'm going to tighten these down. Next, green and yellow. Okay, so this is what you should see as a final result: red, blue, green, and yellow. We're working our way from right to left here. So this is our 9-foot cable. So this is going to connect to our A-axis. So this is going to be on the left side of our machine if you're facing the front. So let's go ahead and locate that position. So on the left side of the machine, you'll see the motor, which we're identifying as our A-axis. So this is the clone to our Y-axis. So whichever direction the Y-axis motor is moving, so is the A-axis. As you can see, these come with the male pins already attached to the motor for your convenience, and they're already paired off into coils. And this is very important because that's the only way that this motor will operate from the controller. So since this has been convenienced, all we need to do is match up our additional wires. Now remember, I told you right to left was the order of the colored wires that we were using. So as we adapt both of our connectors, you will see that each wire corresponds: red with red, blue with blue, green with green, and yellow with yellow. This is very important that you correspond these wires correctly. So that looks good. So let's go ahead and move forward. So following that same process, we are going to use both of our 4 conductor wires that are left over to attach both to our X carriage and our Y motor. So let's go ahead and complete this. Okay, so that's another one down. And since these are both at 6 feet, it doesn't matter which one that you connect to these 2 motors. They're both the same size, so we're going to go ahead and connect this one to our X carriage. So that's located right here. Behind the plates is the motor. So let's go ahead and connect that. So once again, double check that your wires do correspond to the colors. That looks excellent. So let's go ahead and move forward. So let's go ahead and complete our last wire, and we will attach this to our Y-axis motor, which will be located on the right side of our machine. Alright, now that we have this one complete, let's go ahead and attach it to our Y-axis. So located on the right side of the machine if you're facing the front, this is our Y-axis motor, so we are just going to connect our extension lead. Once again, double checking to make sure that those wires do correspond, and they do. So let's go ahead and move on to the next step. Okay, on this next step, we are going to be assembling our micro limit switches. So let's go ahead and gather these parts. 2 micro limit switches, and we also have our 2 conductor wire one being at 6 feet and the other at 9 feet. So the 9-foot cable is going to attach to our x-axis, so along this plane here. And then we have our 6-foot cable, which is going to attach to our y-axis. And what I've done here is I've already assembled one of the microlimit switches to give you an example of how this kit comes together. And also you'll notice that this is in a vertical configuration. How this microlimit switch is going to sit on the axis is just like so. So it'll interact with the plate once it moves along the gantry. So for our second microlimit switch, we need to go ahead and assemble it. So we'll have a microlimit switch plate, 2 M3 self-tapping screws, the microlimit switch, slot washer, 8mm screw, drop-in T-nut, and 2 spade connectors. So to go ahead and assemble this, let's go ahead and grab the plate. And this is going to be in the same orientation as our other microlimit switch. So we're going to configure it onto the plate in a vertical configuration. So we're going to use these 2 holes here. So let's go ahead and grab the microlimit switch. And another thing to take notice to is the indications on the microlimit switch itself. You'll see we have normally open, normally closed, and our common. We are going to use the common and normally open configuration to operate these microlimit switches for our homing cycle. So make sure that these are facing you, that way you know which ones you're connecting to. So with that being said, let's go ahead and mount this microlimit switch into place. Make sure that the orientation does match how you're going to interact with the gantry. So for instance, this is going to mount on top of the 20x40, and our X gantry plate is going to touch the pin in a homing cycle. So let's go ahead and mount that into place, taking the M3 self-tapping screws, and these will tap right into that dowel ring. It's actually relatively easy. Okay, so once that's complete, on the opposite side of the plate, let's add the 8mm screw, our slot washer, and I like to thread on this drop-in T-nut, just like so. So now that that's complete, let's turn our focus to our 2-conductor wire. So what we have to do is connect our spade connectors to the 2-conductor wire. I'm going to start with the 6-foot cable here. So taking our red positive wire here on the cable and our black, we're going to insert that to our spade connectors. You should see the wire come through. From there, I'm going to use these wire strippers with a clamping end, and I'm going to clamp down on top to ensure that this wire is not coming loose. Give it a little tug, make sure that it's fully inserted. Looks good. And same for our additional. So since we have that configured properly, next, taking our X microlimit switch, I'm going to connect my negative to the common, which will be the black wire, and the positive to our normally open, just like so. So now from here, I'm going to move towards the back left side of the machine, and that's where we're going to mount this. Okay, so located here at the back left side of the machine, we're going to insert the microlimit switch here on the top track. And the reason for doing this is we want to allow for maximum travel. Now these black angle corner connectors are going to prevent the gantry from coming all the way to the plate. So we're going to line our microlimit switch with the end of the black angle corner connector on this top track. So taking the microlimit switch and placing it, I'm going to find that position to where the plunger of the microlimit switch will activate when the gantry moves forward. And I'm going to mount this into place. And keep in mind that these microlimit switches are modular, so you can change the orientation of which this microlimit switch is mounted. If you want to insert it into these tracks, you can. We're just giving you a good example of how to maximize your travel on this system in particular, but you can always change this and modify it to your liking. Okay, so what I want to show you here is how the X carriage will interact with the microlimit switch. So ideally what you want is interaction between the plate and the microlimit switch to activate the plunger on the microlimit switch. So as you can see, the pin is activated at the max point. So once it releases the plunger, you'll see that the pin reactivates. And that's exactly what we want. We want that interaction here between the microlimit switch and the plate. You should hear that click, and that's precisely what we want. Okay, so let's move forward. So coming back to our last microlimit switch here, once again, let's go ahead and connect our spade connectors to both of our wires here on our 9-foot cable. Same exact way, we're just going to clamp these spade connectors on each one of our wires. Just like so. And once again, red to your normally open, and black to your common. Just like so. Now let's go ahead and move to the right side of the machine, and we'll insert this micro limit switch for our y-axis. So here on the y-axis, we're going to insert our micro limit switch on the bottom track here. Since it's vertically configured, the micro limit switch is going to be placed like so, and it will have interaction with our Y gantry plate. So let's go ahead and insert this into the bottom track. Once again, making sure that your position is in front of this 20 by 20. That way you have full interaction with the Y gantry plate. So now when the Y gantry comes forward, you'll see interaction here with the plunger. That's precisely what we want. Excellent. So now let's go ahead and move forward. Okay, so on this next step, we are going to be attaching our laser to our front plate here of our X carriage. In addition to that, we're also going to be connecting 2 sets of our 2-conductor wire to this Opti laser. And this is an Opti laser, 6 watt. It's a really nice laser, but obviously this plate can take multiple designs as well as different lasers that you might find on the market. This is just one in particular that I like. So this is the one we're going to be connecting in this video. So in addition to that, you'll have 4 of your M3 screws that come from the mechanical portion of this build. That's what we're going to use to mount this laser. So to start off, first we're going to detach our front plate. So using the M5 ball driver, I'm going to take this plate right off. Okay, so once off, you'll see the additional components here. We have our spacers and our double T-nuts that were behind the plate. So I'm just going to take each one of these screws out as well, keeping the precision shim on the screw. This, so it's easier when we go to put this back on. Just like so. So the orientation of the plate, just remember these 2 holes are always going to be facing the top of the machine. So the laser is going to be aligned here at the bottom. You can see all the different hole spacings here for multiple lasers. So it's really convenient, and this design definitely works with a lot of different lasers. So for the Opti laser, let me go ahead and show you how we're going to align this. So if this is the front of the plate, my laser is going to sit on top, and from the back end you'll see where the 4 holes align. So here and here and here and here. So let's go ahead and attach our M3 screws to each one of these holes so we can secure this laser into place. So as you can see now, my laser is mounted. So from here, let's go ahead and mount this back into place on our front plate. So what I like to do first is insert my screws back to each hole on the sides. So next, adding my spacers to the back end of each screw. Just keep your fingers onto the screws, that way you're not pushing them out. Just like so. From there, I'm going to position this onto my front plate, like so. And adding the double T-nut to the back end here, I'm just going to align it and screw it in with my M5 ball driver. So the same with the right side. And just make sure those screws are snug. And that's how you install your laser to your front plate. So next, we're going to connect our 2-conductor wire to this Opti laser. So here on the top of the Opti laser, you're going to see that each wire is identified. So here we have our 12 to 24 volt power. So this is going to power on the actual laser. So you'll hear the fan activate in the laser. But as far as the signal goes to activate the beam, that's done here in the TTL in and the A and G TTL ground. So this is going to be wired to our controller board. On top, the ground and the 12 volt, 24 volt is going to be powered to our power supply. So keeping that in mind, let's go ahead and wire our 2-conductor wire into these ports. So taking a flathead, I'm going to loosen the ends here for each one of these 4 wires. And this last wire here we are not going to use, so it's just these 4 wires here. Okay, so starting here on the top, so again I'm going to go ahead and describe. We have the ground and our 12 to 24 volt power. So this is going to go to our power supply. So all we want to do is align red with positive and black with ground here. So red's going to go in the first hole here, and then black and to our second. Okay, so give those a nice little tug, make sure that they're fully inserted. You do not want these wires coming loose. So that looks good. So now we're going to go ahead and move on to our signal, ground, and power. So once again, I'm going to go ahead and show you. Black will go to the TTL ground, red will go into the TTL in. So let's go ahead and insert that wire. Both of these wires are the same length, so don't concern yourself with that. And once again, I want to go ahead and reassure you guys that all these wires that are hanging around now are going to be labeled and organized. So don't concern yourself with the mess. So red and black, just like so, and clamp those down. Give those a tug, and that looks good. So let's go ahead and move on to the next step. Okay, on this next step, we are going to be labeling all of our wires here. So as you can see, I have my painter's tape and a permanent marker, and we're going to go through each wire and its point of origin and label it accordingly. And this way we have an idea of which wire goes where to our controller boards. Very important step, so make sure you take your time to do this properly. So let's go ahead and get started. So starting here with our Z-axis, this is actually our laser wire. We're going to label each one of our 2 conductor wires to where they are going to mount. So on the top portion here, we have our power supply connection. So this 2 conductor wire, we're going to trace back to the end. So here it is, and what I'm going to do is use my painter's tape here, just cut off a little sliver. I'm going to roll it around the wire completely, just like so. And I'm going to label this one Power Supply Unit L for laser. So PSU and an L for laser. So now that that's complete, we can go ahead and put that wire to the side. Moving back to the OptiLaser connection, now we're working with our signal wire and our signal ground. So let's locate the end of this wire. So once we have this wire located, I'm going to label this one SL. So it's going to be signal laser. Okay, so once you have that complete, let's move on to our X carriage motor. So right here on the back of the machine, you'll see your X carriage motor. Let's go ahead and locate the end of this wire. Once this wire is located, I'm going to label it X. So X is going to identify the axis that I need to plug in, and it's also going to identify that it's just a motor. Another way to know that as well is this is 4 conductor wire. Everything else is using 2 conductor. So label this one X, and let's move forward. So now, since we're facing the back of the machine, moving to the left side here, we are going to locate our Y-axis motor. So here on this end, you'll see the motor connector. Go ahead and locate the end of that wire. Once this wire is located, we are going to label this one Y. Once that's complete, put the wire to the side, and let's move to our A-axis motor, which will be on the right side of your machine if you're facing the back. So the A-axis motor, locate that wire, and let's trace it back. So once you have that wire located, we are going to label this one A. Once that's complete, put the wire to the side, and let's move to our micro limit switches. Starting here first with the X carriage. So on the right side of the machine, you will find your X carriage micro limit switch. So go ahead and grab this wire and let's trace it back. So once you have this wire located, we are going to label this one XM for X micro. Okay, so once you have that one labeled, let's go ahead and put it to the side, and let's locate our Y-axis micro limit switch, which will be on the left side of the machine. So located to the front, you'll find your Y micro limit switch. Trace that wire back, and once you have it located, let's go ahead and label this one YM. Okay, so once that's completed, go ahead and put this wire to the side, and let's move on to the next step. Okay, so on this next step, we are going to be attaching our flexible tubing to our X carriage. So let's go ahead and gather these parts. We need 2 of our wire clamps, 1 M5 screw, 1 of our drop-in T-nuts, 1 M3 T-nut, precision shim, and 1 M3 12mm screw. So along with that, we're also going to have 26 inches of our flexible tubing. So to start this off, I'm going to go ahead and grab my flexible tubing, and I'm going to insert all the wires here that are connected to the X carriage only. So that includes our laser wires and our motor wire. So taking the flexible tubing, you'll see that there's a split end here, so you can insert the wires all the way down the flexible tubing. Let's go ahead and insert the wires now. So once the wires are inserted into the flex tubing, we're then going to attach our wire clamp to the top end here. So taking the wire clamp, opening it up slightly, we're going to clamp around the end of the flex tubing, moving it to the top two holes here. We're then going to take the M3 12mm screw and our precision shim and insert it through the holes of the wire clamp. From there, we'll go ahead and insert it to the right top hole here. From there, add your M3 T-nut to the back end. So once you have that in place, you can see that we have a sturdy mount here with our wire clamp. So let's go ahead and move to the end of the flex tubing. So here on the bottom end of the flex tubing, once again, we are going to use our wire clamp to clamp around the bottom end of this tubing. And taking our M5 screw, we'll run it through the holes of this wire clamp and add the drop-in T-nut. And from there, I'm going to find the midpoint here on my 20x20, and I'm going to fasten this into place. As you can see now, the flex tubing is in position, and that's looking sharp. So another thing to keep in mind as well, is this flexible tubing is adjustable. So by turning the flex tubing, you can change the orientation in which this flex tubing falls. As you can see, the right or the middle or the left, but as long as it's up out of your workspace, this works just fine. So let's go ahead and move on to the next step. Okay, on this next step, we are going to take our A-axis wires on the right side of the machine if you're to face the back, and run them through the bottom slot of the 20x40. That way we can keep all the wires together once we run it through our Y-axis flex tubing. So what I have here is a 1000mm slot cover that I've cut down 60mm to fit into the slot. So let's go ahead and pan to the right side of the machine and run these wires through our 20x40. Okay, so on the right side of the machine, if you're to face the back, we're going to go ahead and grab the ends of our motor and our micro limit switch, and we're going to run it through this slot here on our plate. So starting with the motor wire, I'm going to run this through first. And then following that, we'll run our micro limit switch through. What I'm doing is I'm just twisting these wires together so they'll fit through. And from there, we're going to run these wires all the way down to our Y-axis, which we'll run through the plate once more and leave with our additional wires. So let's go ahead and run these now. So once you have the wires ran through the slot, let's go ahead and take our slot cover and place this into the slot covering the wires. Okay, so now that you have your slot cover in place, let's go ahead and move on to the next step. Okay, so on this next step, we are going to be assembling our flex tubing to our Y-axis. So let's go ahead and gather these parts and tools. We'll need 2 of our wire clamps, 1 self-tapping screw, an M5 ball driver, spanner wrench, and we'll need a power drill. Along with that, we'll have 28 inches of our flex tubing. So let's go ahead and move to the left side of the machine. So the first thing that we're going to do is take off this nylon hex nut from our black angle corner connector. This is going to allow us to mount our wire clamp. So go ahead and grab your spanner wrench and M5 ball driver, and let's detach this nylon hex nut. Okay, so once you have the nylon hex nut off of the screw, we're then going to take the flex tubing, wrap these 2 wires along with our Y-axis motor wire. So go ahead and start there. So once you have the wires inserted into the flex tubing, let's go ahead and take our wire clamp and let's clamp it onto the end of this flex tubing. So just like so, and from there we're going to attach it to this screw and attach the nylon hex nut. And let's go ahead and finish tightening this down with our spanner wrench. And make sure that the orientation of your wire clamp is correct, so it's facing towards the bottom here, and that looks great. So let's go ahead and take the flex tubing, and we're going to wire it underneath the motor and back towards the end of our machine. So as you can see here, I'm wrapping it underneath the motor and back towards the back end of the machine here. So what we need to go ahead and do is use our self-tapping screw to mount this flex tubing into this 20x20 V-slot. So taking our additional components, our wire clamp, self-tapping screw, we're going to go ahead and pre-thread our 20x20 with the self-tapping screw. And this is just for ease of assembly. Once that's complete, we're going to use the wire clamp, attach it to the flex tubing here. Taking the self-tapping screw, we're going to mount this into place. So once we have that complete, once again, you can always change the orientation of which this flex tubing moves by just twisting and readjusting your position in the wire clamp. So as you can see currently, we have a pretty good position. It's running with the Y gantry, so that's exactly what we want. So in addition to that, we have our Y micro limit switch, and this is going to run in the bottom slot of our 20x40 here. So we're going to use our 500 millimeter slot cover, and we're going to cut that down 40 millimeters so it fits into this bottom slot. Okay, so now that we have this assembly complete, let's go ahead and move on to the next step. Okay, so for this next step, we are going to go ahead and pull out our controller. This is an Xpro controller, and we are going to wire all of our motors up, including our micro limit switches. So with the Xpro controller, one thing to pay attention to is the labels here on each axis. So we have our X, we have our Y, we have our A axis, and our Z axis. The Z axis you won't have to worry about for this instructional video. We are wiring this up for 3 motors only. So since we have a laser attached to our front plate, and we're not using like a pick and place or anything like that, we have no need for a Z axis. So let's go ahead and start by locating our A axis motor. And remember, we labeled all of our motors. So let's go ahead and locate that one. Okay, so once you've located your A axis motor, this is going to be the clone to the Y axis. Since this is a Cartesian style machine and it's running off of a gantry, both motors are moving in the same direction. So this works out perfect with this controller board because it's hardwired directly to include that function. So the A axis is always going to follow which direction the Y is. So the only difference is the motor orientation. Since the motors are mirroring each other, we need to invert this axis. So instead of using red, blue, green, and yellow, we are going to wire this left to right, yellow, green, blue, red. So just follow along with what I do and just remember to invert this axis. So the first thing that we need to do is go ahead and loosen all of these pins. I have mine pre-loosened, and after that we can go ahead and insert the wire. So like I said, starting left to right, I'm going to go ahead and insert in the yellow. Once I have that inserted, I'm then going to tighten it down. Next, we are going to insert green. Okay, so once you have those 2 wires in, give those a tug. Make sure that they're fully inserted. What we want is the insulation to be into this pin. Now, if there is any cross connection between the two, you can blow out a driver. So to avoid doing that, just make sure you take your time and you're inserting these wires fully. I can't stress that enough. This is an expensive piece of hardware, so just take the time to do it right. So we have yellow, green. Now we're moving on to blue. And let's tighten that one down. Give it a tug, make sure it's fully inserted. And last, we'll go ahead and move on to red. Okay, so that's our A axis, and it's been established, and this is an inverted axis, so that looks good. As you can see, also I have my card down here, and this is for a clean surface to set my controller board on. If you have any debris in your workshop where you're setting this up, and it ends up collecting on the back of this controller, you're looking at a short. So make sure that you have a clean surface that you're working on, and that's the best way to install your wires to this controller. So this card works out nicely. So let's go ahead and move forward to our X-axis next, and this will include our micro limit switch as well. So as you can see with the A-axis, we don't have an option for a micro limit switch. That's because the Y-axis is where the micro limit switch will come into play. So once again, make sure all of your pins are loosened for these 2 axes. And let's go ahead and locate our X-axis motor. Okay, so once you've located your X-axis motor, let's go ahead and attach it to our X-axis driver. So here we are going to be inserting our ordered pair as follows: red, blue, green, and yellow. And that's because this axis is not going to be inverted. Now you can invert these axes in the software. We like to follow the color coordination between the motor and the extension. It's just easier to align that to your driver. And if you need to make any adjustments in the software, we'll also go over that in the video. So let's go ahead and insert red and blue first. So working our way from left to right. Okay, give those a tug, make sure that they're fully inserted. That looks good. So next will be green and yellow. Okay, so let's give those a tug. That looks good. So let's go ahead and move on to our X-axis micro limit switch. So once you have this one located, for the micro limit switch section of this controller, we're going to work left to right, so positive and then our ground. So as you can see on the controller board, we have our positive, which is the signal wire, and our negative, which is going to be our ground. So this is all signal control here for the micro limit switches. Once that pin's activated, it sends the signal to the controller board to set your homing sequence or a hard limit if you choose those settings in your software. So let's go ahead and insert red first and then black. Okay, once again, give those a tug. That looks great. So that's the X-axis down. Let's go ahead and move on to our Y-axis. So let's go ahead and locate that motor. So once again, like the X-axis, we are working our colors from left to right, red, blue, green, and yellow. Okay, and then the micro limit switch is going to be red and black. So let's go ahead and get that done. Okay, give those a tug, make sure that they're fully inserted. That looks great. So let's locate our Y-axis micro limit switch. So once again, left to right, red, and then black. All right, perfect. So now that we have our motors and micro limit switches wired up, let's go ahead and give you an overview of what that looks like. So as you can see, my X and Y are red, blue, green, and yellow, red and black for the micro limit switches, and then our inverted axis for the A axis, which is the clone, yellow, green, blue, and red. So make sure that all of those wires do correspond. And let's go ahead and move on to connecting our laser. So if you remember from the previous steps, we have labeled this one SL for signal laser. So this is going to connect to our controller board. The other two conductor wire will connect to the power supply. So we need to make sure to connect this to the proper sections of our Xpro controller board. So here on the output section of the controller, you'll see an M for the motor, and you'll see this symbol here, which stands for the ground. With this two conductor wire, red, which is our positive, is going to be activated through the motor tool section of our software. So the red's going to connect to the motor, the black is going to connect to the ground here. And this is the signal for the laser. So once again, we want to go ahead and loosen these pins. And I'm just going to twist these wires, making sure I get a really good connection here. So again, you do not want these wires to come loose. Okay, so inserting the red to the motor here. Let's go ahead and place that. Okay, perfect. So now that we have our controller board wired up so far, the only additional things that we're going to connect to the board is our power supply, of course. We need power to control the board, and our fan, which is going to plug into this output here. So now that we have this complete, let's go ahead and move on to the next step. Okay, so on this next step, we are going to be assembling our open case. So go ahead and pull out your open case kit. You should see all of these parts included. So you have your hex standoffs, your M3 20mm screws, M3 16mm screws, 4 nylon spacers, 3mm aluminum spacers, 2 slot washers, 8 M3 T-nuts, 4 precision shims, 2 drop-in T-nuts, 2 M5 15mm screws, and of course your brushless fan and your open case plates. So along with that, we're going to use our ball driver set to assemble this. And of course, we already have our Xpro controller wired up. We're also going to be mounting this to our plates. So to start off, let's go ahead and grab one of our plates, and taking our M3 20mm screws, what I like to do is go through each corner of the open case plate. So go ahead and stick one screw through, and then we'll thread on one of our hex standoffs. And we'll go ahead and do the same thing for the additional corners. Okay, so once you have that complete, we are going to move our attention to our controller board. So with the Xpro controller, we have mounting holes here on the open case plate that fit with these holes here on the controller board. So it's a really easy mount. What we need to do is just grab our M3 16mm screws along with our nylon spacers and sandwich that onto our open case plate. So taking one of the 16mm screws, you can see I just run it through this hole here. And on the back end, I'm going to add one of the nylon spacers, just like so, and follow suit with the additional 3 holes. Okay, so once we have these screws configured with the spacers, we are then going to take the plate, and you'll see the inside 4 holes here are going to align to your controller board. So go ahead and insert the screws. Okay, so once you have the controller board placed onto the plate, holding firmly to the plate, you don't want these screws to come out, let's go ahead and thread on our M3 T-nuts. So one screw at a time, what I like to do is just go ahead and thread those. Okay, so once the T-nuts are threaded onto each screw, you can then take your ball driver and just snug these into place. Alright, so that completes the assembly to one of the plates of the open case with our controller. So now let's move forward to our second plate, which will be the assembly to our brushless fan. So when attaching the brushless fan, I find it easiest to insert the screws first to the open plate and then add the precision shims for the spacing for the fan. So let's just move our controller out of the way. And on the plate, we are focusing on these outer holes here. And this is where our fan is going to mount. So taking the M3 20mm screws, we're going to insert from the back end of the plate. And from there, I'm going to rest this on its back. And then I'll go ahead and add my precision shims. So to each screw, go ahead and add your precision shims. And from there, we can add our fan, making sure that the sticker is facing you. This is the direction the airflow is going to come from. So let's go ahead and stack that on top. And from there, go ahead and add your M3 T-nuts to each screw. And you can hand tighten these, that's fine. You really don't want to over tighten the system and crush your fan. Okay, so that completes the assembly of our fan to the open case plate. So from here, we're going to go ahead and bring back in our front plate here with the controller. And what we need to do is go ahead and insert our M5 15mm screws into the placement where these screws will be mounting to the V slot. So next to the controller here, next to these 2 slotted holes here, which are for zip ties, as you can see on both ends of the controller, we're going to insert our 15mm screws. So from the back end of the plate, we will then add our additional components. So starting with the 3mm aluminum spacer on each screw, followed by our slot washers. And next we will use the drop-in T-nuts. So just threading these on to the screws. And now this is ready to be tightened down to the V-slot. Now we're not going to do that yet. I'm just going to keep this to the side along with our additional assembly with the fan, because we need to go ahead and hook up our power supply and add power to our controller board, and also organize the wires within the case before we close this case. So the additional screws are for tightening down the case completely onto our standoffs. So just carry these over into the next step, and let's go ahead and move forward. Okay, so moving forward to the next step here, we're going to be connecting our power supply unit as well as connecting the power wire to our controller board here. So in this step, let's go ahead and gather these parts. Our power supply unit, which you see we have our power case assembled to the power supply unit. And if you have any questions about that assembly, we do have a video dedicated to the assembly of the power case, and I'll put that in the description below. So Once you have that established onto your power supply unit, you will also need your 2 additional connectors. These are 2-pin male connectors. And then you'll need, of course, your power cable to the power supply unit. And you'll also need your power cable that'll run power from the unit to your controller board. So let's go ahead and get started. First, by taking the power cable, as you can see, I already have this stripped down. Let's go ahead and establish a connection to our 2-pin male connector. Twisting these wires together, go ahead and insert the wires into this connector. Now, once again, make sure you loosen these pins on the inside of the connector. You want to establish a true connection to the power supply unit. So positive on the right side and negative on the left side. So once you connect it, go ahead and tighten down. Give that a tug, make sure that they're fully inserted. That looks good. So on the other end of this power cable, this will be connecting to our controller board. So moving over here to the controller. So here on the controller board, you'll see this blue plug. This is to provide power to the controller. So go ahead and loosen those pins, and we'll prep it for the connection of the power wire. So once again, red is positive, black is negative. Here on the controller board, you'll see positive and your ground. So black will be for the ground, red for the positive. Let's go ahead and establish that connection. Give that a little tug, make sure that they're fully inserted. That looks great. So now let's go ahead and move forward to our fan connection. So here on the controller board, you will see an indication here for fan. And it's this white plug here, and you'll see positive and negative. So we need to connect the red side of the plug to the positive, black to the negative. And that will provide power to your fan. Okay, and so the last thing we need to do on this step is just go ahead and plug in our power cable to the power supply. So right here on the power supply unit, you just simply plug it in. It's that easy. So in addition to that, we still have our 2-pin male connector that we are going to connect to our laser. Go ahead and find that wire. You can see we have it labeled power supply unit laser. So once again, go ahead and twist these wires. Red will be positive and will be on the right side of the pin, and black will be negative. And remember, make sure to loosen your pins. Once you establish that connection, go ahead and tighten it down. Give that a tug, make sure they're fully inserted. And this will go into the output of your power supply. And the additional plug that provides power to your controller board will also go into the output of power supply. Just like so. Excellent. So now that we have that complete, let's go ahead and move on to the next step. Okay, so on this next step, we are going to be using our zip ties to tidy up our machine. So all the electronics and things like that, we just want it to look aesthetic. So let's go ahead and start off with our controller wires. So what I've done here is I've bundled all of my wires. So anything that's excessive, I've bundled all those wires together because they can seat underneath the controller. And it's not going to interfere with the cooling of the board because I'm going to lay it here at the bottom portion of the open case. So I like to keep the excess wire just in case I want to configure this differently. So I'm going to lay this bundle underneath the controller. So you can configure this differently. You can cut off the excess and mount it wherever you like. That way you don't have a bundle of wire. But what I like to do is just lay it underneath, and I'm going to mount my controller on the left side of the machine here. So taking this bundle of wire, I'm going to lay it underneath the controller board, just like so. And taking our top plate, I'm going to seat this on top of the bottom section. So once you have the plate on top, let's go ahead and use our additional screws that were left over, the M3 20mm screws, and we're going to go ahead and tighten this down. Okay, so now that we have this encased, we're going to use these 2 portholes to tighten this down to our 20x20 extrusion. So let's go ahead and use our M5 ball driver. So here on the left side of the machine, I'm going to mount this into place. So as you can see, I'm using the portholes that were designed on this plate for this purpose exactly. And just make sure those drop-in T-nuts grab, and that looks excellent. So now as you can see, I still have left my power wire on the top portion of the board. That way I can move my power supply anywhere that I like. So here on this portion of our flex tubing, you'll see that my laser wire that's connected to my power supply unit is away from the other wires that we are going to be zip tying and tying down to our 20 by 20. So that is the purpose of making sure the power supply unit can be transferred to any location, which is essential when moving the machine around in the shop, or if you just want a different mounting position for your on-off switch with the power supply. But that looks sharp. So we have our open case established here on the 20 by 20. It's mounted into place. It's sturdy. That looks great. So let's go ahead and move forward to zip tying these additional wires, just making sure everything looks nice and neat. So taking some of the zip ties here, I'm just going to zip tie along these wires to bundle them together. That way they look like one unit. So generally I'll put like a 1-inch space in between each zip tie. And what we can also do is just go ahead and zip tie this to our 20 by 20 extrusion here, just so it's completely hidden. So let's go ahead and snip off the excess of these zip ties. What I like to use is snips, or we can use scissors. And that's really looking nice and neat. So let's go ahead and zip tie this to the extrusion. What you can do is double up on the zip tie. Generally, I'll just cut off that excess before I mount it. Alright, that's looking nice and neat. Perfect. So let's go ahead and move to the right side. So, same thing with these additional wires here. Just kind of tuck it into the slot there. And let's go ahead and cut off the excess. That's really starting to look sharp. So let's go ahead and move on to the rest of the machine. There's a couple other places that I want to go ahead and zip tie. So the connectors that attach to each motor, what I really like to do is zip tie each one to make sure that there is no pulling motion that's going to disconnect your motor. So let's go ahead and move forward. So here on the left side of the machine, if you were to face the back, what I'm going to do is zip tie this connector together, going through each sets of motor wires and zip tying it down, just like so. And let's go ahead and do that for our additional motor connectors. Alright, so now that we have that complete, let's go ahead and move on to the next step. Okay, so for this portion of the video, we are going to download our machine control driver. So let's go ahead and open up our browser. From here, we are going to enter in openbuilds.com and select the OpenBuilds control machine driver. From here, you'll see an option we have for Windows, Mac, and Linux. The machine driver that I'm going to use personally is for Windows, so simply download the Windows exe. Once it downloads, you'll see a prompt here that says Windows protected your PC. Just select more info and run anyway. Run through the prompts and install. And finish. And you'll see that your OpenBuilds control has started. So go ahead and select that. Now that we have our OpenBuilds control software downloaded, we need to go ahead and insert our serial port to our controller board. From there, connect the USB to your laptop. And up at the top left corner here, you will see options for COM positions. We need the second one, which is COM 19, and connect. Now, another thing to keep in mind is we are not powering on our machine at all. 5 volts is provided to your controller board through the USB connection. That's all we need to go ahead and configure this into our software. So we need to change our parameters and make sure that our controller's firmware is updated. So let's go ahead and first, you will see an unlock alarm state. This is for the purpose of safety. So anytime that you plug in or unplug your controller board, you will see the unlock alarm start flashing. And all this does is prevents the machine from being jogged until you are ready. So just a safety precaution, definitely a nice thing to have just in case there was an instance where the machine was moving and you didn't want it to move, or if something went wrong. It's just a nice feature. So let's go ahead and unlock the alarm first. And at the top here, we're going to go into Gurgle settings. And here we have load default settings. So for every machine that OpenBuilds provides, we give you a default setting. So it uploads the parameters that we have found to be most suitable for the machine, which is very convenient. You don't have to go through and do the calculations yourself. So all you have to do is select the machine type that you have, and from there all your parameters and values will be inputted into your controller board. Very convenient. So what we have here is the OpenBuild Acro 510. So by selecting this, you'll see custom firmware required. So basically, since our machine is a 2-axis machine, it runs off X and Y, we need to upload the firmware that is specific for this machine. So for homing, if you had a 3-axis machine, where it would start would be the Z-axis. So since we only have 2-axis, we need to upload the firmware to where the controller board knows there is no Z-axis on this machine. So all you have to do is select yes, and from there it's going to upload the firmware to your controller board. Okay, so once it's uploaded, you'll see the COM positions come back. So let's go ahead and select COM 19. And once again, your unlock alarm state is going to activate. Just click that, disengage. And now that we have our firmware uploaded to our controller board, let's go ahead and power on our machine. Okay, so now that we have our machine powered on, let's go ahead and jog the machine around, make sure that everything is functioning correctly. So here we have directions. We have negative movements and positive movements. For this machine specifically, we have X and Y. You don't have to worry about the Z unless you installed a motorized Z axis. So here I'm at 10 millimeter increments. I'm going to jog this to the right. And as you can see, this is a positive movement, and that is functioning correctly. So now let's go ahead and move our Y-axis. A positive movement will be back towards the controller board. That looks good. And a negative movement, of course, comes back to the front of the machine. And for the X-axis, it goes to the left. So we also have our homing cycle that we need to check, just to make sure everything's functioning correctly, and our micro limit switches are also functioning correctly. Now before we run the homing cycle, I want to show you a nice feature to this control software. Here in the troubleshooting tab, we have options here for end stops. And what this does is allows you to see which micro limit switches are functioning correctly and which aren't. So what we need to do is go ahead and test each one. First, by selecting which micro limit switch you are going to activate. I'm going to select the Y, and what you will see once I activate this is the alarm state will turn on. And the reason it does this is because we have hard limits enabled. So don't freak out when you see that the alarm state was triggered. The software is just doing what it's supposed to do. So if there's any instance where the machine is going in the wrong direction and it hits a micro limit switch, your machine will stop moving, which is very nice. I love this feature. So leaving the alarm state on, let's go ahead and select the Y-axis micro limit switch one more time. As you can see, it turns on. So we have a signal to the micro limit switch. That's perfect. And the same for the X. So let's go ahead and check the X. And as you can see, it turns on. So now that we have our micro limit switches checked and they are working properly, let's go ahead and unlock our alarm and go back to the control. From here, let's go ahead and hit a homing cycle. So up at the top here, you'll see the home all. Let's go ahead and select that. And as you can see, the machine is moving to the X-axis first, and then it will locate the Y-axis. So moving to the front here, it will complete the homing cycle. It goes back at 5 millimeters, which is part of our settings, and finds its homing position. Very convenient for any type of manufacturing. When you're running a job that's all the way in the back right corner and you just want to home your machine, that's how you do it. You just press a button. It's awesome. Very nice and very intuitive. The software in itself is amazing. Definitely state of the art. As you can see, we have more functions here too. We have a jog widget, which you can select and scan the barcode with your phone, and you can jog your machine through your device. It's really convenient. Awesome. We also have G-code editors, macro settings. We have the 3D viewer, which I really like. You're able to watch your project work in real time, which is awesome. So now that we have everything configured into our control software, let's go ahead and move on to our CAM software, where we will upload our first project to our machine. So let's go ahead and get started. So coming back to the browser, let's go ahead and open up the OpenBuilds CAM G-code generator. You'll see an option to browse to. Go ahead and select. We'll start with the new workspace. If you've delved into the CAM G-code generator before, it will save your last instance. For this specifically, we're just going to go ahead and start with the new workspace. Make sure that our settings are inputted correctly. So let's go ahead and select settings here in the settings tab. And we need to make sure that all of our application settings are correct. So our controller is the Spark Concepts Xpro. Our machine is the OpenBuilds Acro 510. If you have a different machine selected, all you have to do is hit the scroll bar and find your machine. So the 510 is correct. Our tool that we're going to be using is the laser. So turn laser on is the section that we have selected. And all of the customized defaults are correct. This is all based on the machine profile. Everything looks good. So let's go ahead and save that. And from here, we're going to go ahead and upload a workspace that we have created for this machine specifically. We want a raster effect, so it will burn into the material, creating a nice laser etched design. So coming back to the workspace, I'm going to upload a file. And this file I will upload to the build page, so you'll be able to access this as well as a link on the YouTube description. So if you want to find this file specifically and just follow along with the video, it will be available. So I'm going to go ahead and select the file and open drawing, which you have DXF, SVG, image, Gerber, Celion. All these different files are an option. And what's really cool about this is you can just drag and drop an image into this CAM software, and it will go ahead and generate G-code for that image. It just has to be a plain black and white image, but it's super powerful, really cool that you can just drop an image into this. It's just very user friendly and just really cool software. Outstanding job, OpenBuilds. So let's go ahead and open the drawing. And I'm going to go ahead and grab and drag this image down into the CAM. And as you can see here, it's calculating the toolpaths. And here you see the image that I've inputted into the CAM. It's kind of a three-dimensional look here, which is really awesome. So as you can see, it's kind of tilted to the side here. We want a nice, cool rastering effect and just kind of make this stand out. So since we have this uploaded into our machine profile, let's go ahead and transfer the G-code to the OpenBuilds control software. So right here at the bottom right corner, you'll see transfer G-code. Go ahead and select that, and it will upload to your control software. And you'll see it here in the 3D view, which is awesome. All right, so now that we have our project in place into our controller, now we need to go ahead and set up our material for this cut. Okay, so facing the front of the machine here, as you can see, I've moved my X carriage over slightly towards the middle. Just for reference, in this video specifically, I want you guys to be able to see where I'm placing the material and how I'm placing it on this table. So the material that I'm going to be using is a scrap piece of wood here. As you can see, it's quite thin, and it's approximately 7 inches by 5 inches. And what I'm going to do is tape onto the surface with double-sided tape and place it underneath my laser, which you can see here. I have the Opti laser 6 watt, and the position is dialed in as well. I have my plate all the way down to its furthest position, so this acts as a Z-axis manually. So what I'm going to go ahead and do is just go ahead and tape this and mount it to the surface here underneath my laser, and then from there we'll adjust our position to start the project. So let's go ahead and get started. So once I have the double-sided tape in place, I'm going to place it underneath the laser here, find a position that works for me in the center of the machine. And that's another thing to keep in mind. This position can be placed anywhere within your machine profile. So as long as you set your 0 point to the front left corner here of the material or anywhere in the material, you can always check the size in the software, which I'm going to show you guys. It's really cool. But just make sure that this is square. I'm just going to adjust the position here, just making sure that this is square to my machine. You can just kind of eyeball it. So now that we have our material in place here, let's go ahead and move back to our software, and let me show you some cool features that are also in the software. So we have the check size feature here, which is really cool for our machine. Now before we go ahead and select this, I want to show you our digital readouts. So our DROs, also known as digital readouts, we have our X and Y. Like I said, Z doesn't matter, we don't have a Z axis on this machine. But before any type of manufacturing is conducted, you need to make sure that you set your 0 point, which is basically a starting position for your project. So for our X, Y, we need to go ahead and select the 0 point, and this is where our machine will register the starting point as. So since we're currently at this position here, I'm going to go ahead and check the size. As you can see, the machine is going to go ahead and show you the parameters of the design, which is awesome. You can't beat that. You get a preliminary trial of how this machine is going to run this job, essentially. So you can always check the size based on the material to make sure that you have the right sized material and you're not going to run off of the machine's full extent. So that being said, what I want to do is go ahead and adjust the position slightly and try to center this as best as possible. You can always do measurements, which is the most accurate way to do this. I'm just going to go ahead and run this through. This is a scrap piece of wood here. I'm going to go ahead and bring my machine over slightly. As you can see, I've selected 1 millimeter increments, and now I'm moving to 10. So that looks pretty good right there. So first starting position, as you can see, now my X has moved 30 millimeters, 31 millimeters. So go ahead and select the set 0. And as you can see, all the digital readouts here are zeroed out. So now this is my new starting position. So now if I were to move the machine around anywhere into the workspace, let's say I want to move my machine out of the way so I can put more material down or something different. Let's go ahead and move our Y-axis out. Just want to show you how accurate this machine is. It's going to come right back to the 0 point. So now let's go back. Let's go to 0. It's right back at the starting position. So this is the starting project position. So let's go ahead and we need to gather some safety equipment. If you're using a laser, you will need your safety goggles. Do not run a laser without these goggles, period. Safety is the most important thing here, guys. You always want to conduct a manufacturing job safely. So if you have any issues as well, I also want to mention that you can power down your machine by simply flipping the switch on your power supply unit or unplugging the machine. So always stay safe. So now that we have our project starting position established, you can see our digital readouts are reading 0 here at the start position. So now we can go ahead and run this job. Once again, make sure to wear safety goggles. So now that our job's complete, let's go ahead and home all, just so we can access our workspace. And grabbing my material here. And as you can see, that project turned out great. Just look at the line work here. This machine is insanely accurate. That turned out perfect, guys. Excellent job. Alright, thanks for tuning in, guys. The machine turned out great. Thanks for tuning in. Make sure to subscribe to the channel, hit that like button, and dream it, build it, share it.